Hello everybody, welcome back to a new video. Today we're going to be talking about forced percussive lead sounds, which is really interesting. There's a little bit of an interesting thing going on here, which I want to talk about regarding referencing in sound design. If you want to make a sound, how you go about doing that. I wanted to do a full tutorial on that, so if you would like me to do that, you can leave that in the comments down below and I'll get to it. But this is a very cool example of one of the tricks I tend to use when doing sound designing, particularly when I want to recreate a sound. So without further ado, let's get into it. Alright, so the sound that I wanted to recreate is, I don't remember which track it was, but somebody sent it to me, and it sounds like this. If I can find out which track it was, I'll put a link in the description so you can listen to the full track. But here it is. So if we loop that, you can hear we have this percussive element in there, and there's actually two versions of it, which we're going to talk about in a little bit. So we have that glassy top version, and we also have that one at the start, which you can hear in here. You can hear that there's two things. One is a little bit lower in the frequency range and one is a little bit more up there. So what I started to do when I heard this sound, and I heard that it's actually two distinct sounds that makes up this whole thing, what I decided to do is to just open up an EQ and set it to specific frequencies, which basically played out the whole sound in such a way that I could find out where the frequency was coming, or which part of the frequency spectrum the sound was playing in. And you can hear for this first one that this entire sound basically plays in this very small region of the spectrum here. And then there's that top one, which also sits in part of the same spectrum as that other one, but also has a lot more stuff going on in the higher end. Round about here. So with that in mind, I decided to start designing the sound. Now, it wasn't completely the same. It's in a little bit of a different key and it has a little bit of a different tone, but the idea is there. And the main focus for this sound is indeed going to be that the blocking of certain frequency regions to put them into their own little area of the spectrum. So let's get into this first patch, which sounds like this. Just a very simple patch here. And what's going on is we're basically just generating a nice gritty tone here with the oscillator A going through a comb filter. And then to make it plucky, what we've done is we've set up this envelope as kind of a pluck and also routed that to the filter. If we turn it off, you can hear that it kind of loses that pluckiness a little bit. Versus, you can really hear it has a little bit more pluck. And finally we have this macro 1, which just applies asymmetric version here, which in this part of the sound I don't think we used because it only starts playing here for the second one, so you can ignore that. Then we go into the delay, where we do the delay trick, and we have set up some frequency, which again for this particular version kind of changes for the second run around, which is something you could do. I've actually let this play twice, and you can hear the first one is a little bit different from the second one. Both by setting the notes to different octaves, as well as kind of changing the frequency region in which this delay works here, and as well with that macro 1. But that's not really the whole point of this sound. The whole point comes kind of afterwards. Once you have like that plucky sound that you really like, it now comes time to put it in its own little area of the spectrum. So what I've done is just put on an EQ which kind of acts like a bandpass filter, and that's how it's set up. It's just a bandpass filter sitting down here, and it's kind of putting it in this little range here. If we take it off, you can hear and we also take this bandpass filter off, you can hear that it normally has a lot bigger spectrum. So by turning this on, you can really put it in its own frequency range and kind of emulate the sound. Even if the exact sound isn't the same, it kind of still will sound like it. Once you have like the dynamics the same as well, it will really start to sound similar. So we've basically done the same thing for this. This is just the exact same sound, only that the delay type is set to a much higher or a much lower value. Therefore it sounds higher in pitch because the repetition is faster, therefore higher in frequency and therefore higher in pitch. If you watch my channel before, you probably know already what this trick is. If you want me to do a full video on this delay trick, I can do that. But basically what you need to know for this is that what we're doing with this is we're taking the incoming wave and repeating it so fast that it basically recreates a new waveform. And this particular timing is set up that it is exactly the time it takes for one complete cycle of whatever key we pressed. So in this case it's G. So this is how long it takes for a note in the key of G to cycle once. Now there is one octave to it. For example, if you want to lower the octave, you have to double this. So you would go 5.10, and I know from memory that for it to work in the sub-bass region, you have to set 20.4. So it takes 20.4 milliseconds for a note playing at G0 in Ableton, which is the sub, to complete one cycle. So if we set it back to 2.55, that's going to be G4, because it's 4 times lower, I believe. It's divided in half 4 times. If yeah, that works, I believe. My math is not my strongest point. So that's the only difference here. And of course that we have a different frequency region that we're playing it in. And again, from this, I've basically just kind of copied over the frequency region in which it was most prevalent and use that. You could, for example, just turn this lower a little bit, and you get that little extra harmonic there, and it will overlap a little bit more if you're looking for that. So it will sound like this. And then to get the kind of cohesion back a little bit, what I did, because it really sounded too much like two different sounds. So what I did is, without the bandpass filter, it really sounds like two different sounds. You can hear that it's not really the same sound. So this bandpass kind of helps there, puts it all through the same bandpass and makes sure that the same movement is on both of the sounds, and that helps making them sound similar. That's also the reason why the delay is on these two here. Actually, what we've done is we have set up slightly different delay timings. So there's a little bit of, there are some points where, for example, the delay from this note is going to line up with the delay from this note, because of the delay timings being slightly different. So that again helps with the cohesion of the whole sound. And that was what I wanted to talk about, using multiple sounds and kind of putting them all in the same frequency region here. So yeah, that's it for today. If you enjoyed this video, leave a like. And if you're new here, subscribe. The channel has been growing a lot lately, and it is really nice to see that you guys enjoy this. So I hope to see you next time. Bye bye.